The hindbrain sits right on top of the spinal cord and contains the pons and medulla, which do basic functions that keep you alive. The midbrain sits right on top of the hindbrain, and it coordinates really basic visual and auditory processing. Let's get to know these structures in a little more detail. So if we examine the brainstem, the first structure that you'll notice is known as the medulla oblongata. And the medulla is responsible for heart rate and respiration, for a couple of really basic human reflexes like vomiting and sneezing, and for regulating the sleep-wake cycles that help you keep your body on an even keel. Really basic functions. Just above the medulla, you'll find this sort of swollen looking area, and that's the pons. The pons essentially functions as a little information superhighway in the brainstem. So this is where a lot of the cranial nerves come in, and it's also got input coming up from the spinal cord, and then it's responsible for projecting that into the rest of the brain. There's also a really special small area of the pons that produces sleep and regulates dreaming, which we'll talk about towards the end of the course. If I was going to sum up the function of the hindbrain in just one phrase, it would be staying alive, because this is the brain region that functions to keep you alive. And because of these really basic life or death functions that the hindbrain is performing, a stroke or other damage to the hindbrain is typically fatal. So above these hindbrain structures of the medulla and pons, there's a small but important area known as the midbrain that we'll take a look at next. So here's where the midbrain is sitting. This is a view of the brain from the back. So the back of the skull would be here, and you see it sitting on top of the hindbrain. And this is a cutaway from the side, and you see it sitting on top of the hindbrain down here. An interesting fact about the organization of the brainstem is that it still follows the law of Bell and McGindy. So incoming afferent sensory fibers travel up the back of the brainstem, and outgoing messages travel down the front of the brainstem. So the back of the midbrain, as you see it here, is responsible for really basic processing of audio and visual information. So information from the auditory nerve and ocular nerves enters here and is coordinated and sent on to the rest of the brain. And here on the back of the midbrain, there's just a little bit of coordination between audio and visual functions. So if there's a bright flash and a loud sound behind your shoulder, your head will automatically whip around and locate the source of that sound and sight. And it's structures here in the back of the midbrain that allow you to do that, to snap your head in the direction of important information. Another structure that you can't see from the surface that's sitting just behind these areas that process sound and visual information is a special spot for sensing pain. So it's here in the brainstem that your body detects physical pain. It's up in the limbic system and the cortex that your body decides how to feel about the pain and what to think of the pain, but basic pain detection is happening here in the brainstem. So this area here on the back of the midbrain that's responsible for producing that orienting motion that allows you to look in the direction of a loud sound or an interesting sight is called the tectum. And you don't need to know that term, but I just want to help you connect what I'm saying here to what you'll read in this chapter of your text. So this brings us to a basic and important point. These lower areas of the brainstem we're discussing follow the same rule of Bell and McGindy that the spinal cord did, meaning that sensory functions are all located in the back, which is also known as the posterior or dorsal side, and motor functions are all located in the front, also known as the anterior or ventral side. I'm going to try to avoid using these terms, but I'm just putting them here so you can connect what I'm saying here to the reading. So that means that when we look at the midbrain, it's in the back where these sensory functions like orienting motion and sensing pain are happening. I'm also going to give you a look at this special area that is for sensing pain when we discuss what the front of the midbrain is doing. So let's take a look at that view. So the front of the midbrain contributes to movement and motivation. And this brings us to a really basic and important point. So the lower areas of the spinal cord, and in the front, the midbrain is contributing to movement. So I'm going to show you what it looks like in the front of the midbrain. Don't be intimidated by the detail in this image. Let me talk you through it. So here is the back of the midbrain, also called the tectum, that we just discussed, where orienting motion is produced. And then to show you what's going on in the front of the midbrain, they've taken a slice and they've put the slice up here. So we see these areas that are responsible for really basic sensory processing. And then here, this is the area that detects physical pain. It's called the periaqueductal gray. You don't need to memorize that. And then here up in the front, we should expect to see some motor functions. And in fact, these different areas, which are all just named for how they look, this is sort of substantia nigra is Latin for dark spot, and the red nucleus is sort of a reddish area. These are these brain regions are responsible for producing dopamine, which is the neurotransmitter that fuels movement in the brain. So it's not important that you remember these details now, just remember the big picture that the front of the midbrain contributes to movement and the back of the midbrain contributes to sensory processing.